sign convention. Lecture 2.1. It's very laggy. So, we use the passive sign convention, so-called, by the electrical engineers. We're going to define it here, and then we're going to also look at a figure that sort of tries to illustrate it. So, power flowing into a component is considered to be positive. Power flowing out of a component is considered to be negative. That's really the sign convention. So there are a couple different ways that you can mean sign convention. This actually fully defines the current and voltage definitions relative to each other for a given element. However, when we look at a circuit, we have to determine the sign direction, assumed direction, and that's also called sign convention sometimes by people. So it's really just use it interchangeably. The first one, though, is defining power in and out to be positive and negative, respectively. Okay, so the figure that I was referring to, 2.1, is this. So if you have a passive element, it's got power flowing into it. The power is considered greater than 0. An active element is one like a source, right? That's delivering power to the circuit. And so power is coming out of it, and so power is going to be considered to be negative from an element like that. Okay. Because power is equal to the product of the voltage and the current, VI, this implies the current and voltage signs are prescribed by the convention. For passive elements, the electrical potential must drop in the direction of positive current flow. This means the assumed direction of voltage drop across a passive element must be the same as that of the current flow. All right, for active elements, it's like the opposite, which supply power to the circuit. The converse is true. The voltage drop and current flow must be in opposite directions. Figure 2.2 illustrates the possible configurations. So on the left, we have passive elements. And for a passive element, the direction of voltage drop is from a plus sign to a minus sign. That's the way we write it on there. So this is just any element. It could be a resistor, a capacitor, an inductor. The voltage drop across it, we have to draw the arrow of the assumed current flow in the same direction as the voltage drop. So if we drew the voltage drop from plus to minus this way, the current would have to go that way. If it goes from top to bottom plus minus, the current goes that way. We can never have the plus, minus, and the arrow pointed. The plus to the minus needs to be the direction the arrow points all the time, is what it comes down to. So like this or like this, fine, but it would be incorrect if we said, oh, for this resistor here, we're going to assume that plus minus for the voltage, and then, oh yeah, we'll have the current flow this direction, the assumed direction of the current flow. This is no. We can't do that. We can't do that and be consistent with our sign convention. We could do it. It's just that we would have to redefine our sign convention. So we don't want to. Stay in the box in this case. Don't think outside of it. Okay. So that's for a passive element. Now, for an active element, exactly the opposite is true. The direction of the drop is the opposite the direction of the current flow. So the current flows from minus to plus for an active element. Okay. This is like the standard sign convention that virtually everybody uses in electronics. Some of the other countries use the same sign convention, but they just use different symbols. And so like a voltage drop in a lot of places is you drawn an arrow like this for voltage drop instead of the way we do it with the plus and the minus. That's an American thing. So, but they pretty much universally use the same sign convention. All right. They also use different symbols for this stuff, and it's confusing. I don't like it. Not one bit. Okay, so, all right, we've got, good. When analyzing a circuit, for each passive element, draw an arrow beside it pointing in the direction of assumed current flow and voltage drop. Try it on figure 2.3. So that's on the next page. So we actually have the source is already defined for us. We'll talk a little bit more about why that is, but we already have current flowing assumed out of the positive terminal of the voltage source, which is consistent with our sign convention, right? Which is that for an active element, a source, we assume the current flows out of the positive terminal, right? From minus to plus. All right. For the rest of these things, we have to decide which direction we're going to assume the current flows and voltage drops. So since we've coupled these things together, whichever direction we assume the voltage drops is the direction the current flows, we can either draw on the assumed direction of the current flow or the assumed direction of the voltage drop, and they're the same, right? So we could either draw in a little sign like this or like this, which tells us the direction of the current flow or voltage drop that we assume for that element. Or we could do like a plus minus, right, for the voltage drop. So those are the two possibilities. I kind of like using the arrow method. So like this next to the element is the easiest, or you can draw the full arrow if you want. Either one is totally fine. So we need to do that for each element. And we could choose that for this one. So which of these is correct? So this arrow or this arrow? Yes. They're both correct. So it's fine. We can choose it to go this way, or we can choose it to go this way. It's arbitrary because these are passive elements. It doesn't matter which direction we choose them to be. We just have to stick to it. It's just like defining a coordinate arrow in a physics problem. You just have to stick to whichever direction you choose. So I would say it's typical to draw the voltage drops and the current flows away from sources and towards ground. But that is totally up to you. You don't have to do that. And some people define it in terms of a loop. But in this class, I'm going to encourage us to all use per element. So you could draw one for the capacitor, for this resistor. You could draw this one up. That's fine. And you could draw the one for L1 down. That's fine. If it becomes ambiguous as to which element you're trying to draw the arrow for, I encourage you to just put it beside the element, the arrow. Either one works. Okay, so that is the sign convention. You can label these any way we want, any way that you want, but you cannot do it this way. You can't point down on the assumed current flow direction from the source. And why is that? Because the sign is already established for the source, right? The source is actually something that we can't change the sign of. If you connect the positive terminal to a certain place, you can't be like, well, I'm going to assume that's the negative terminal. You can't. You're stuck with however the source is connected to the circuit.
Same principle for like a AA battery. When they have a positive and minus sign, you can't flip that.
Right, yeah. If you connected the positive side of the battery up to a circuit, then you couldn't do your circuit analysis and be like, I'm going to assume that positive terminal is actually the negative terminal. It doesn't work. We're going to talk a little bit more about that in a sec, but yeah. Yeah.
For like diodes and stuff
Mm-hmm.
that have specified flows,
Mm-hmm.
those are more passive, like they're not putting out. But
Yeah. So we'll talk more about diodes, but the same thing applies. I mean, for a diode, we typically are going to put the assumed direction of current flow in the direction the diode is going to allow current to flow, in the forward bias direction,
okay.
because that's typically where the direction the current will flow. But that's just actually arbitrary too. You could technically have it the other way. It's just that your diode current would always show up negative, or
Okay.
virtually always show up as negative value. Okay, so the purpose of a sign convention is to help us interpret the signs of our results. For instance, if at a given instant a capacitor has a voltage of 3 volts and it has a current of -2 amps, we compute that the power is equal to the product of the two, right? So 3 times -2 is -6 watts. And we know 6 watts of power is flowing from the capacitor into the circuit. That's how we were able to interpret it, because our sign convention, we established our current and our voltage in accordance with our sign convention, which says, a positive power corresponds to power flowing into a component, and a negative power corresponds to power flowing out. So since we computed it to be a negative power, we know that the power is leaving the element, flowing out of the element. For passive elements, there is no preferred direction of assumed voltage drop and current flow. If a voltage or current value discovered by performing a circuit analysis is positive, this means the assumed and actual directions are the same. For a negative value, the directions are opposite. So let's say that we did our circuit analysis and we found out for this circuit, we discovered that VC2 was equal to -2 volts. Okay. Which direction is the voltage dropping across C2?
Opposite.
Yeah, the opposite of the direction we drew the arrow, right? Means that, voltage is actually dropping from this node to this node. You guys, this is very similar to how, you guys have done this probably in physics too, but yeah. This is how sign conventions always work, right? You can interpret the results based on the convention. It's actually pretty easy for electronics. It gets a little harder for mechanical systems, but we'll talk more about that later. Okay. Yes. For active elements, we don't get to choose the direction. The physical situation prescribes it. For instance, if a positive terminal of a battery is connected to a certain terminal in the circuit, we cannot simply say, meh, I'm going to call that negative. It's positive whether you like it or not, Nancy. It's a little joke there. A little joke. You guys know that one? Negative Nancy? Yeah. It's positive whether you like it or not, Nancy. See? I mean, I know. It was really clever. I liked it. Okay. So that's any questions on sign convention? It's just everything you've come to know and love about sign conventions. Yes.
Why did it drop the opposite way on that second capacitor again?
We don't know. I mean, it's we don't know what VS is. We don't know what the
Okay.
current time is, but just say that it was at a certain time -2 volts. We would be able to interpret that as being a drop in the opposite direction of the arrow.
Okay, that's fine.
Yeah.
And that's just because it's a passive element.
That's because it's a passive element, and we assumed that, or our assumption was that
It's
is dropping this direction, but it came out negative, which means it's actually dropping the other direction. So, I mean, I just made that -2 volts up.
I got you.
I did not just analyze that circuit on the fly. Yeah. But speaking of analyzing circuits, I'm glad you brought that up.